Congratulations on responsibly disposing of your waste by placing it in a recycling bin. As a dutiful citizen, you may believe that your job is complete, but the recycling process entails more than meets the eye. Surprisingly, only a fraction of the materials actually get recycled. So what happens to the rest? The recycling journey begins with the collection of recyclable materials, which can be done through various methods such as curbside programs, drop-off locations, and commercial recycling services. For efficient sorting and processing, it is vital for consumers to separate recyclables like plastics, paper, glass, and metals from non-recyclable waste. Once collected, these materials are transported to a recycling plant or center. This hub plays a critical role in the recycling process, where recyclable materials are sorted, processed, and prepared for further recycling or manufacturing. These facilities, spanning from 7,000 to 8,000 square meters, handle a staggering 400 tons of waste daily. Upon arrival at the recycling center, recyclables are unloaded from collection trucks and taken to the facility's tipping floor. Here, workers or automated equipment conduct an initial inspection to remove obvious non-recyclable items like large trash or hazardous materials. After this inspection, waste undergoes a pre-sorting phase, during which large or easily identifiable non-recyclable items, such as cardboard and large plastic objects, are manually removed. Recycling centers employ a combination of manual labor and advanced sorting technologies. Automated conveyor belts, screens, air classifiers, magnets, and optical sensors play key roles in this process. These technologies sort materials based on various properties, including size, weight, shape, and material type. Rotating screens, for instance, separate materials based on size, allowing smaller items to fall through while larger ones continue down the conveyor. Powerful magnets attract and separate ferrous metals, such as steel cans containing iron. Sensors and cameras identify and separate materials based on their optical properties, such as color and shape, effectively sorting plastics by resin type and color. Air jets are employed to separate lightweight materials like paper and plastic from heavier materials like glass and metal. Despite these advanced technologies, manual labor remains essential in the sorting process. Workers stationed along the conveyor belts manually remove contaminants and items that the automated systems may have missed. This manual sorting helps ensure higher quality recyclables. Once sorted, the materials are compacted or baled for easier handling, storage, and transportation. Baling involves compressing materials like paper, plastic, cardboard, and aluminium into large blocks or bales. These bales are stored in the recycling centers until they are ready to be transported to manufacturers for further processing. Proper storage is crucial to maintaining the quality of recyclable materials. However, it is important to note that some non-recyclable or difficult to recycle items, known as residue, may still be present in the sorted materials. Recycling centers are responsible for managing this residue, which may include items like plastic bags, food waste, and small non-recyclable pieces. Once baled and sorted, the recyclables are sold to manufacturers and processing facilities as raw materials, continuing their journey towards becoming new products. Each material necessitates distinct handling to prepare it for eventual reutilization. For instance, paper undergoes shredding and is mixed with water to form a pulp. This pulp subsequently undergoes thorough cleansing and refining processes, eliminating ink, adhesives, and impurities. The resulting refined pulp can then be utilized in the production of fresh paper products. Plastics, on the other hand, are sorted according to their types and subsequently undergo processes such as shredding, washing, and melting to generate plastic pellets. These pellets serve as the fundamental raw material for manufacturing new plastic products. Similarly, glass is crushed into small fragments known as cullet, which is then melted down to create novel glass products, thereby diminishing the requirement for raw materials and conserving energy compared to manufacturing glass from scratch. Metals, such as aluminium and steel, are melted down to form ingots or sheets. The recycled metal derived from this process can be employed in the creation of a diverse range of products, spanning from cans to automotive components. Processed materials are subsequently dispatched to manufacturers who utilize them as essential inputs for the production of fresh merchandise. The integration of recycled materials in manufacturing operations reduces the demand for pristine resources, ultimately conserving energy and mitigating greenhouse gas emissions. The newly manufactured products, crafted from recycled materials, are then distributed to consumers through various retail outlets. These products, boasting the same quality and functionality as those manufactured from virgin resources, provide consumers with the opportunity to actively support the closed-loop recycling system and endorse sustainable practices. There exists a possibility to perpetually recycle certain materials, such as aluminum, without compromising their quality. However, it should be acknowledged that other materials may have limitations on the number of times they can be recycled due to their propensity to degrade. Not all waste can be recycled due to various technical, economic, and environmental constraints. In fact, a substantial portion, approximately 60%, of the waste that finds its way into recycling bins cannot be effectively recycled. A significant proportion of non-recyclable waste is ultimately directed towards landfills, which are carefully engineered sites designed to contain waste and mitigate its impact on the environment. It is important to recognize the potential environmental risks associated with landfills, contamination of groundwater, the generation of greenhouse gases such as methane, and the possibility of long-term pollution. Another course of action for non-recyclable waste involves its incineration in waste-to-energy facilities. This method entails burning waste to generate energy, typically in the form of heat or electricity. While incineration can decrease the volume of waste and recover some energy, it is crucial to note that it may also release harmful pollutants into the atmosphere, thereby contributing to concerns regarding air quality. In order to minimize the amount of waste directed towards landfills and incinerators, it becomes imperative to implement waste reduction and minimization strategies. These encompass practices such as source reduction, which involves producing less waste at the outset, as well as the reuse of items and the composting of organic materials. It is evident that the proper management of waste necessitates a holistic approach, taking into account the limitations and considerations associated with recycling, landfills, and incineration. With strategic waste reduction and promoting sustainable practices, we can work towards a more environmentally responsible and resource-efficient future.